Okay, we're going to start some trigonometry, and up to this point we've dealt with right triangle trigonometry, which obviously is a triangle that is right. However, now we're going to deal with things that could be acute or obtuse, and we're going to use what's called the law of sines and the law of cosines in order to figure out missing sides and angles and things like that. And it has a lot of very practical purposes, but before we get any further, let's do this. This is completely, totally essential. Take your calculator. Press mode. You need to be in degrees. If you're not in degrees for these problems, you're going to miss every single problem. So you go down to degree, press enter, and then you can quit, which would be second and quit. There you go. Now we're ready to start. Up at the top of the paper it says that the law of sines states that for any triangle with vertices labeled A, B, and C, this is true. And let me kind of break this down for you a little bit. First of all, let's look at the picture that they supplied. The big angle, or the vertices, the corners, are capital letters. And the sides that are across from it are lowercase letters. So, for example, capital A is a vertex, it's a corner, across from side A, lowercase a. Capital B is across from lowercase b. Capital C is across from lowercase c. And that's going to be the case. Even if it's not A, B, and C, capital M will be across from little m, things like that. This will make sense in just a minute once we get into the first problem. So what we're going to do, I do want to point out something before we move on. We're going to use any two of these. This proportion holds for all three, but for example, if I only know A's and B's, then I'll just use that much of it right there. If I only know B's and C's, I'll use that much. And if I only know A and C, then I'll use just those right there. Here, try to cover up the middle one. Okay, let's use the law of sines for number one. Find the length of any labeled side or angle, and round all side lengths to the nearest hundredth. Round all angle measurements to the nearest degree. So here we go. For number one, let me point out what we do have. We do know big B is 17 degrees. We also know the one across from it, which must be little b. We know big A is 43, but what we're looking for is this x right here, which, if you want to be fair, this is the same thing as little a. We know big B and we know big B and we know little b. We know big A and we don't know little a. So we're going to use this portion of the formula right here, just these first two. So let's just start by rewriting that. Sine of capital A, the corner, the vertex, angle measurement, over little a equals sine of capital B over little b. And now we'll just fill in the numbers, and I don't know if you've thought this far ahead yet, but we're going to have to cross multiply. So the sine of capital A, that's 43 degrees, divided by little a. And we don't know little a, and it's called x. So we're going to put an x down here. That is equal to the sine of capital B. That's an angle measurement. The capital letters are angle measurements. The sine of 17 degrees, if you want to put the degree measurements, you can, divided by little b, which would be 10. Okay, we're going to cross multiply. Now, in the process of using trigonometry, it is very easy to lose some precision by rounding too early. So we're going to carry the decimals with us as we go. So when we cross multiply, we're going to have 10 times the sine of 43. Let's go ahead and write that down. Now, I'm not going to use the calculator yet. I'm just going to write 10 times the sine of 43 degrees. And that's going to be equal to x times the sine of 17. I'm going to put the x in the front here, and then I'm going to put sine 17 degrees. If you put sine 17x, then it's going to look like the x is with your 17. I'm just going to put the x in the front. In order to solve for x, we're going to have to divide. So let's divide. Let's divide by the sine of 17. It's going to cancel those. Now, don't panic because we don't have too many numbers yet. We're going to get our numbers in a minute. We're going to divide by the sine of 17. This is where the calculator comes in. X is equal to this. Now, if we would have used decimals, we would have got an answer that's probably pretty close, but sometimes it's not. And also, for what it matters, in the calculator, we'll need to put the parentheses around the degrees. I should have put it around that actual symbol right there. So here goes. Let's type it in, see what we get. 10 times the sine of 43 divided by the sine of 17. Close the parentheses. There we go. The direction said to round to the nearest hundredth if it's a side. So here's our final answer. We'll put it in red. X is equal to 23.33. And just to be fair, let's put the units. 23.33 feet. Okay, I'm going to walk through this problem again really quickly just to let you know what happened. We're looking for the measurement of a side, and we're going to use the law of sines. We know, excuse that bell. We know A and we know B. There's going to be another bell in a couple minutes. Ignore that one too. We know capital A and we know capital B and we know little b. Knowing that we're dealing with A's and B's, we come up here and we grab this piece of the formula. We'll ignore that one. We fill in the numbers. I want to point out a very common mistake. When people cross multiply, they don't know what to do with it. They know the phrase cross multiply, but don't know what to do with those numbers. It's 10 times this, and that is equal to X times that, and then use that to solve. Okay, let's do number 2. Number 2 actually is going to start very easily. It's going to start in probably the easiest possible way. We need to find everything we're missing. We need to find X, side length. We need to find Y, also a side length. And we need to find theta, which is the measurement of an angle. Now, it's going to involve the law of sines. And it's going to involve the law of sines more than once because I have a Y and I have an X. I've got a couple side lengths. So the law of sines is going to have to happen twice. Let me tell you the easy part though. We can find this theta very easily. Once upon a time, someone told you this. The measurement of all three angles in a triangle adds up to be 180 degrees. So we're going to subtract 45 and 63 from 180. And we get 72. So I'll put some degree symbols on there. So I'm going to start filling in things as we find them. We already know one of the things. We know that theta is 72 degrees. Okay, let's start investigating and see what we have. We know capital A, we know capital B, and we now know capital C. We also know this is 10 feet, and this is opposite. It is across from capital A. Sorry, I pointed to B and said A. Because this is across from capital B, that's what I meant to say, sorry about that. I need to learn my alphabet. Since this is across from capital B, this is little b. Let's label that. This is one of the things we're looking for. And it is across from big A, so it's little a. We're looking for this as well. It's across from big C, so we're looking for little c. Okay, so far we've identified that this is 72, and we also know we have to find A and we have to find C, or X and Y, depending on what letter you want to call it. I really don't care. It doesn't matter what you start with, but let's just pick a couple to start. Let me point out one of the main things about the law of sines right here, though. In order to use the law of sines, you have to have an angle and the side that it's across from. We know B and little b. So because we know that, we'll be able to use the law of sines. So I'm just going to start by finding A. which would be x. So we're going to start the same way we did the last one. Sine of capital A over little a equals sine of capital B over little b. And let's start filling some stuff in. Sine of 45 over, oh my goodness, we don't know it, but it's x. And that's equal to sine of 63 over 10. Now, a minute ago, I had said something about how we needed to know these two things, and because we know both of those, we're going to use both of those. So let's go ahead and cross multiply. This looks a lot like the last problem. 10 times sine of 45. 10 sine 45 degrees. I'm going to try to get in the habit of putting the degree symbol. It's equal to x sine 63. There we go. We're going to divide and find out what x is. We will divide by this because it's hanging around with the x, so we'll divide by the sine of 63. And x equals whatever that is when we type it in the calculator. So here goes. 10 sine 45, close parentheses, divided by sine 63. There we go. It's said to round the length of the sides to the nearest tenth. So we're looking at a side length of 7.94. And this is in, what is it, feet? Yeah, it's in feet. There it is, 7.94 feet. And that's fantastic. But we have three things to find. We have to find theta, found it, have to find x, found it, and we have to find y. So in a separate problem, or a separate setup, same problem, we need to find the other one too. So we're going to go with, first of all, let's fill this in, 7.94. Okay, before we get too crazy, keep in mind we are looking for the measurement of we're looking for the length of segment C. Because we're looking for this, we're going to need to use the one across from it. If we're looking for little c, we better be using big C. So, our formula better involve this piece right here, sine of C over C. Let's use those two right there. Now you're probably thinking, why am I using those? The reason you're using these is because we know big B and little b. See, there they are. You want to know something else? We also know big A and little a. We could, if you wanted to, set the rest of this problem up using these two right here. I just wrote on my finger. I'll get over it. All you need is a side and the angle across from it, and you're good to go with the law of sines. I'm going to use these. Okay, here we go. Sine of big B over little b equals sine of big C over little c. Sine of big B, that would be 63. Over little b, that's 10. And that is equal to the sine of big C, which is 72 degrees. There I go, leaving that degree symbol out again. And it's over, well, it's little c. We could also call it y. We're defining it both ways. And now we're going to cross multiply. Doesn't matter which order you go in first. I'm just going to say it. I'm going to call it y times sine 63. So y sine 63 equals 10 times the sine of 72. Now we're looking for y, so we better divide by the sine of 63. I'm going to cancel those. We grab a calculator and we type it in. Okay, we just found y. Y is equal to 10.67 feet. Let's put the units on there. Okay, we have just measured everything that was missing. That's 10.67 feet. This one was also feet. We found theta, we found x, oops, we found y. I just bumped the camera, and that's why it's shaking. Okay. The next video will explain the next couple problems.